Hello, and welcome to Summarize Science, where we break down fascinating research for you. Have you ever wondered why it's so hard to make a humanoid robot move with the same grace and skill as a person? This paper from researchers at Stanford University dives deep into one of the biggest hurdles, translating human motion onto a robot's body. The core problem is what they call the embodiment gap. Humans and robots have different body shapes, limb lengths, and joints. Simply copying joint angles from a human to a robot often results in unnatural or physically impossible movements. These glitches, or artifacts, can be pretty jarring, such as the robot's feet sinking into the ground, its body floating in the air, or even its limbs intersecting with each other. Obviously, these are major problems if you want to train a robot to perform a task in the real world. To address this, the researchers developed a new process they call General Motion Retargeting, or GMR. The goal of GMR is to create a more robust and faithful translation that avoids these glaring artifacts. Their method is a sophisticated multi-step pipeline that carefully maps human body parts to the robot, scales the motion correctly, and uses optimization to find the most natural robot pose. This is a smarter way of translating movement, rather than just directly copying it. The researchers then set up a competition to see how well their GMR method worked. They pitted GMR against 3 other retargeting methods, including one from the robot's manufacturer, Unitree. They used a diverse set of 21 motions, including walking, running, dancing, and even kung fu. Success was measured by training a simulated robot on each motion and seeing if it could perform it without falling or failing. The results were very telling, as some of the other methods produced significant flaws. For example, one method often resulted in the robot's feet penetrating the ground during a dance motion. Another method caused the robot's arms to intersect with its torso when trying to run. But what about how the motions looked to the human eye? The team conducted a user study where 20 participants compared motions generated by GMR to the other methods and chose which one looked more faithful to the original human video. The results showed that people overwhelmingly found GMR's motions to be more realistic and closer to the source than 2 of the other leading methods. While the manufacturer's data was also very good, GMR proved to be a powerful and effective new alternative. So, let's recap the important points and what this all means. First, this study proves that getting motion retargeting right is absolutely critical for teaching robots. Even small, seemingly minor flaws like feet clipping through the floor can make a motion completely unlearnable for an AI policy. The researchers' new GMR method effectively mitigates many of these critical artifacts, resulting in motions that are not only more visually appealing, but also more useful for training. Looking to the future, this work is a crucial step towards a world where robots can learn complex physical tasks simply by watching humans. Imagine a robot in a factory, a care facility, or a disaster zone being able to learn a new skill on the fly without complex programming. Improving this fundamental translation layer between human and robot is key to unlocking that potential. That's all for this episode. Thanks for watching Summarize Science.